This is all about using built-in functions in C. So groups of related functions in C are stored together in what are called header files. Actually, the truth is what are called function prototypes are stored in the header files, but this goes a little bit beyond the scope of this lesson, and we'll talk about that a little bit later. In order to be able to use a function that is in a particular header file, that header file has to be included. And this is done with what's called a preprocessor directive that starts with the little pound sign or hashtag and the word include. And this goes before the main function. Essentially what a preprocessor directive does is it tells the system to do something before compiling the code. In this case, it says to load the specified files. The two most common header files that we will use are the standard input and output. We include this with the pound or the hashtag include, and then inside of the less than symbol and the greater than symbol, this stdio.h. The .h is for the header file. And also the math header file, which is included with include math.h. Okay, so the standard input-output header file, stdio, notice that it's not studio. That's a really common mistake. What this header file does is it includes the functions that are needed for both input and output. In C, the basic input function is called scanf, and that reads in from the keyboard. And the basic output function is printf, and that prints the results to the screen. The output function is what we're going to need in order to be able to see results from actually running our code. The math header file includes a lot of math functions, so let's run through these fairly quickly. We've got the square root function, the exp function, exponential function, natural log is the log function. We have trig functions like sine, cosine, tangent, and note that all of these are in radians by default. We have the pow function that has two arguments, x comma y, and what that does is that raises x to the y power. We have a couple of different absolute value functions. The abs function is the absolute value function for integers. FABS is short for float absolute value, so that's the float absolute value function. And then we have a couple of rounding functions. Ceil rounds a float value x up to the nearest integer, and floor rounds the float value x down to the nearest integer. There are some random number functions in C, and there are two header files that we generally include when generating random numbers. The standard library header file, stdlib.h, and the time header file. The reason that we include the time header file is that the seed is obtained from the built-in clock, and functions to do that are in the time header file. So we need to include the time header file in order to set the seed for the random number generator functions, which are in the standard library. So here's how you set the seed in C. So setting the seed, first of all, for the random function should be done only once in the very beginning of the program. And then after that, you can call the random function as many times as you want to generate random numbers. So to set the seed in C, the function is called srand. And again, you pass to it time, and this argument has to be null. So srand parentheses time parentheses null semicolon at the end of a statement, as in all statements in C, is how you set the seed. So you do that once in the very beginning of the program. After you set the seed, you can call the rand function to generate random numbers. So the rand function generates random integers in the range from 0 to rand max, which is a built-in constant in C. No arguments are passed to the rand function. So what that means is that in C, when you call it, you give the name of the function rand and then empty parentheses. So you can use the division operators to modify the range of the random integer that is returned. So for example, to generate a random integer in the range from 0 to n, use the expression rand parentheses and then %n. So that's going to be the remainder in the modulus division operator divided by n is going to give you a random integer in the range from 0 to n. If you want a random integer in the range from 1 to n, just take that same expression and then add 1 to it. And then if you want to generate a random float instead of an integer, use the typecast operator. So say float and then your expression, for example, rand parentheses divided by n. So here are a couple of examples. Rand percent modulus 100 plus 1 is going to generate a random integer in the range from 1 to 100. Float, rand parentheses divided by rand max, is going to generate a random float in the range from 0 to 1.